Those things still go. So, just send
Okay. Any volunteers for the notes, the minutes? Thank you. JavaScript? Francesca? JavaScript? Perfect. Shall we start? Sure. So let's start. If your intention is not to be an ace, then you're in a wrong room. Oh, so please have a look to the not well. We can emphasize on the code of conduct. So please be kind when you go to the mic. And the agenda. So do you want to say something or? So let's start with the first presentation. Ist.
1 second. Ludwig Seitz, minor agenda bashing NIT. I will be presenting the DTLS profile, not Göran.
Okay, perfect. We'll call you Goran then. And Peter, is Peter here?
Yeah, that's me.
This will be fun.
You want me to click or?
Yes.
Okay.
Well, we'll see. Let's go to the next one.
There we go.
Yeah, that's good. Good day, EST of Co-op S. This is a small reminder of what it is doing. It looks at EST, but instead of HTTP and TLS, it uses Co-op and DTLS for constrained devices. We have two application areas identified. One was to add to be used in the Brisky context. Another one is distribution of identities independent of Brisky. Please go on.
You should be able to just click.
Okay.
Yeah, I'm fine
Okay.
doing that.
So we have had a working group last call, which has ended as far as I remember. We had many thanks to Jim, Esko, Klaus, and Karsten for all their remarks. We think we have taken them all into account. We have discovery and content format negotiations. The next slide will be about that. Have been clarified and corrected. We have added another application area, which was asked by ESCO because he had this fantastic parser, which was so fast. He wanted that, so that sounded correctly. We had some difficulties in interpreting correctly RFC 7250. These have been corrected as far as I know. And we have updated the example. We made a very, how you call it, not very correct assumptions about how accept was used. This has also been removed. There were some typing errors also removed, so the whole thing looks much more clear. The DTLS sections, we had 2 DTLS sections, one which explained why it was necessary and why it fitted in the context. Another DTLS section said why it was so handy for the application and what was being used by it. So we merged all that, which was nice. And in general, I think the document has become much clearer thanks to the working group last call comments. So thank you very much for all that. Any comments, please do not hesitate. So this is about a multi-part payload. In the server key generation, what is returned are 2 types of media types. And thanks to the core working group understanding, we have had the multi-part content format has been defined in which it is possible to specify different content formats which are sequentially follow each other in a CBOR array. This was great until the moment we had actually the possibility to either continue to send back PKS-C7 or to send back PKIX in one of the parts. And we saw this was all very simple. We just mention it somewhere and we do the accept option. Then it was pointed out that the only thing we can accept was the content format for the 62, and that there was not much negotiation going on here. So that was a pain in the neck. But after several discussions on the mailing list, thank you all very much for the helpful remarks. So we finally decided to have an additional pass, one which is called SKJ, which returns the PKS7 and the PKCS8, and the other one which returns the PKC8 and the PKIX. We have had no contraindications about this solution. So if anyone thinks it should not be done, this is the moment. No? Great. No, so this slide is valid. We think we are done. So we still need to have to define the TPD 287, but once this goes into the whole continuation, I think this will be automatic.
Right. So from the chair's perspective, right now, I'm trying to verify that we have actually addressed all the working group last calls. And as soon as I have done that, then I will push the publish button.
It's my pleasure.
Any comments? No, it's a bullshit.
No compliments? Okay, thanks. Cheers.
Let's see. Hello, Ludwig Seitz. I'm going to present the updates in the draft IETF ACE of ALF, which I called framework, and in a companion document, the draft IETF ACE of parameters, which I call the params document. So I've split these updates into several slides because there's a lot of updates since the last IETF. We saw version 16 at the last IETF, and we added a lot of things already version 16 to 17. So it was pointed out to us that we were saying the RS receiving an access token needs to verify it, but we didn't say what verifying meant. So I added a section that explains what steps the resource server needs to go through to verify a token. We got a comment that we were creating a very dangerous endpoint here of info and that we're not giving any guidance on how to protect that against attacks. So now there's a section that is saying that you shouldn't permit any actions on the children resources of info. You should only allow posts on that resource, and you should implement some rate limitation to prevent attackers from like cramming in random invalid requests to that and overload the resource server. We had a mechanism of token expiration based on sequence numbers, and as in our discussion, it turns out that it's very likely that every device will have at least a real-time clock chip. We removed that because it was designed for devices that don't have any clock, and the discussions indicate that this is unrealistic. We added also, it was pointed out, we required secure communication between all the entities, and we weren't saying what secure communication actually meant. So we added a section that specifies all the known things that you probably already know and expected, but now it's explicitly said. So we want encryption, integrity protection, replay protection, freshness, and binding of the response to the request. Then we have a number of updates. I crammed 2 version numbers into one slide here from 17 to 19. We added the definition of authorization information. Oh, sorry, you wanted to?
Yeah, one question on the last point is binding response to request. Is that, which interface is that?
That is when you are interacting with the token interface, with the introspection endpoint, and with the resource server. So in some way, you need to know if you get a response back, to which request was that related, so that an attacker cannot serve your old responses.
Right.
And that applies to any interaction. Like if I do a request for a token, I want to know that an attacker is not suppressing the real request and sending me some fake token back. There is unprotected interactions where we cannot do that. If you interact with the authorization info endpoint, or if you do an unauthorized request, then there's no way of doing that. But all the protected interactions should fulfill that.
Okay. I'm wondering whether we create some new protocol requirements there, do we?
I think TLS, DTLS, and OSCORE do that.
Okay. If that's what
I would be very surprised if they didn't.
Karan Saini, Center for Internet and Society. Do you think it might be useful to add what amount of rate limitation should be implemented for that endpoint? Because currently the draft does not.
Yeah, that would be very application dependent.
I see.
I mean, you could have endpoints that have very low rates. Say an endpoint that's using a LoRaWAN network, they have a very low data rate, and this would be very different for an endpoint that is connected
But
to
perhaps in the security considerations section, you can explore all the different applications.
Whoa. That would be a pretty comprehensive work. Would you please post that to the mailing list so that it gets a discussion going? Because I am not prepared to answer that comprehensively on behalf of all my co-authors now. But I want to keep that in the loop. Okay, next, authorization information. So it was pointed out to me that we were speaking about claims of a token as the information that the resource server uses to decide whether an access was allowed or not. And it was pointed out to me that there's other information like keys and lists of trusted keys, etc., that are not covered by these claims, but that are relevant for the authorization decision. So I looked how OAuth was wording this, and OAuth used the term authorization information, but it didn't seem to me that it was explicitly defined, so I just went ahead and added the definition in the terminology list. So it's now defined to be whatever information the resource server uses to determine access rights. And sadly, it's very easily confused with the term access information, which is the additional information the authorization server returns to the client in addition to the token. So all the things that the client needs to know, like the proof of possession key, the profile, the token type, etc. So don't confuse those two, please. Then Jim, in his very comprehensive reviews, pointed out that this information object I called AS information, which is when you do an unauthorized request to a resource server, it returns to you an information object that basically tells you, this is the authorization server you need to go to get a token to access me. Jim pointed out AS information was not really a good descriptive name for this information object. And in lack of a better name or shorter name, we ended up calling it AS request creation hints, because that's what it is. It gives the client hints on how to create a request for an access token at the AS. We also added some functionality, optional functionality there, so you are required to return the address of your AS, and you can optionally also say, and for the resource you wanted to access, you would need to request this scope, and by the way, you can address me with this audience, so that you can, as a client that doesn't know anything about the resource server, you can query it in that way, and then build a valid request for a token that will work with that resource server to the AS. So it's a functionality that supports clients that have no previous configuration telling them how to talk to the RS. And it's optional, so if you have like everything pre-configured, then you just skip those message fields. We added also a key identifier to the AS request creation hints. This supports a mechanism where you already have an established security association with the resource server, and at some point you hit the 401 unauthorized, and you say, damn it, I want a new access token to give me that access, but I want to avoid redoing the DTLS handshake. So please bind this new access token to the same security association or the same proof of possession key that I'm already using, so that I can skip redoing the DTLS handshake. So that's what this key identifier is about. Then we had a long discussion about security considerations for multi-RS audiences. So if you have an access token with an audience claim, and the audience claim identifies a group of resource servers. Basically, there are a lot of questions around this. One conclusion was that you cannot use a symmetric proof of possession key here, and you cannot use a symmetric key to protect this access token here, because otherwise any member of this resource group can change the access token or can impersonate the client towards other members of this resource group. So there's a new section in the security consideration that elaborates on that problem. And I was told I need to provide expert review instructions for the registries that map parameters to abbreviations. So I did that, copying generously from both the CWT draft and the COSI draft. Thank you for your input. And finally, now we're stepping up the numbers to the current or almost current version. We had a discussion about the keys that the client uses to authenticate the resource server. So Steffi pointed out that as a client, there might be situations where you're sitting on an access token, you don't know that it is expired, or rather, you're sitting on a key for the resource server and you don't know that this key is no longer valid. And then you're sending requests to this resource server that might contain sensitive information. Like if you're doing a post request that contains, say, a firmware update. You don't want to use an expired key for that. So currently there was, or at that point, there was no way for the client to know whether these keys were still valid. So we added some text about this. The conclusion we came to was that we need to couple the validity of these keys, RS keys, to the validity of the token, because there is no way to decouple those in the OAuth model. There's no way to track separately whether the key you use to authenticate the RS is still valid, unless you have like a PKI infrastructure, which we assume you don't in ACE. So basically now the problem boils down to the client needing to know whether the token has expired or not, and the token is opaque to the client. So there are several ways for the client to learn whether its tokens are expired. One would be to do introspection, and there is going to be another presentation about client introspection later if we manage to keep the time. The current recommended mechanism is that you should use the parameter, or rather the authorization server should use the expires in parameter when sending the access token back to the client. In OAuth, this parameter is recommended. We are now saying that if you as a client get a token and cannot determine whether this token is, when this token expires, then you should not use it, which implicitly says use expires in, or any other means at your disposal, but if you don't have any, then don't use the token. So it's kind of making this expires in a bit more than just recommended. Anyway, next one was, we had a section with IANA mappings, and it was saying that a certain number range of abbreviations required specification. Jim pointed out to me that this would be very, very ridiculous specifications. You would have a specification that says the OpenID claim assertion has the abbreviation 47, full stop, end of spec. And that sounded really not like a good use of specifications. So we changed the mapping sections, only those, to only use expert review for the shorter number ranges and private use for the very large number ranges, so that you don't have to write a whole specification just to register an abbreviation. And finally, error responses. So we had a number of required error responses when the RS was receiving and processing a token, and there were errors in that process. So we were saying you should respond with 401, 403, etc. Olaf pointed out to me that if you use the mechanism in the DTLS profile, where you're sending the token in the DTLS handshake, you don't have the ability to return these error responses, these RESTful error responses. You can raise some DTLS errors, but they don't map to the RESTful errors. So now it is optional for the RS to give an error response, which is probably in general a good idea, because there are situations where you don't want to tell a potential attacker what was wrong with his request. So you may not be able or don't want to respond with error messages, and now you're allowed to do that. So that was the changes before. Go ahead.
Thanks, Ludwig. Could you go back one slide, please?
Of course.
Yeah, sorry. Robin Wilton. I think if I caught it right, under security consideration for multi-RS audiences, you noted that symmetric key protection didn't distinguish between different users of the key, and you said the draft was updated.
Yes.
What with?
Sorry?
Did you just update it to say symmetric keys aren't appropriate in this case, or did you?
Yeah, should not, I think was the term, or must not. I'm not 100% sure what I did there. I think must not.
Okay.
For multi-RS. It's in the security considerations. I can look it up.
Thanks.
Okay, so these were the changes up until Jim pressed the publication required button, because at that point we thought we had addressed all the comments. Sadly, a few days after Jim pushed the button, we got another comment that turned out to be a review, actually. So, I got the order of my slides wrong. I was going to talk about the params first and then about that. So let's do the params first. Params was a document we split out of the framework. And the idea here was that we're using this document to define things that OAuth is working on in parallel, and that at some later point in time, they might want to supersede, like invalidate. And to avoid them to have to invalidate the whole ACE framework, we split it out into separate drafts. So if at some point they make something that breaks or changes this, they can just update this one and obsolete it without obsoleting the framework. So this just contains the whole confirmation parameters. Hannes?
I was wondering whether you also included the resource parameter in addition to the audience. The audience is the logical name, the resource is the absolute URI, and in some cases one or the other may be more appropriate depending on what you want to do in the OAuth document. So if it's not there, it would be just one additional registration for the parameter. I'm just saying.
So at the moment, let me just go through this bullet and then it will become clearer. What we did is two things. We added a lot of examples for every of these parameters. And then we had a long discussion about our required audience parameter that we defined and found out there is an equivalent parameter in the OAuth token exchange specification, which is called audience, not to confuse with AUD, A-U-D, which is the audience claim, which can also be used as a parameter meaning something slightly different. So since this and this had exactly the same semantics, we struck that out of the params document. It's removed. And instead, we defined a mapping to audience in the framework. We haven't defined a mapping for resource, which now strikes me as a bit odd. We could actually do that without any issues. It's just like specify a number, abbreviation number for the parameter and say, use it like it's defined in the resource indicators draft. So this is what we did on that. And then Jim pushed the publication required button, and then I got a comment that was actually pointing out some problems, not big problems, but unclear parts. So we will have to do some changes. Most of them are already in the version I posted on Tuesday or so. So there's a version 23 now of the framework and a version 05 of the params. And there were some issues with the parameter mapping, sadly. Apparently, when I changed it in one place, I forgot to change it in another. So I aligned all of this, made a big table to make sure that all the mappings were correct now, and I'm really hoping they are. We're going to mess that up by adding resource now, but hopefully that I will be able to do that without more problems. Then it turned out in this question that a parameter we had taken from the DTLS profile, because we thought it was generic enough to be in the framework, was now underspecified, or rather the processing of that parameter was underspecified. So this parameter, which was originally called nonce, and then we discovered that OpenID has already registered a parameter called nonce, so we had to change the name, is a parameter that the resource server sends back to you when you do an unauthorized resource request. And the idea is you have a resource server with an internal clock that is not well synchronized with the AS's clock. So it cannot verify an expiration claim in an access token it receives. So instead, it sends a nonce to the client, and the client is supposed to send this nonce on to the token endpoint, and the AS is supposed to include that nonce into the token as a claim. And then when the resource server receives the token, it can see, oh, there's a nonce that I recently issued as a claim in that token, so this token is reasonably fresh. So it's another freshness mechanism for not well synchronized clocks. Hannes?
When you say not well synchronized, one of the feature, if I remember correctly, we added sort of the lifetime of the token in seconds, which doesn't require synchronized clocks, so
Yep.
or absolute time. So you are talking about something else when you talk about synchronization of clocks between the RS and the AS, right?
No, there's several mechanisms now to deal with clocks between RS and AS that are not synchronized. This is one of them. The other one is this expires in claim.
Right.
That tells the resource server, when you receive this token, look at this claim, it contains a number of seconds, and you start counting now. And when these seconds elapse, then you throw the token away. This is another way of dealing with expiring. But
That you're talking about the other mechanism then.
Yeah.
Okay.
there are two mechanisms for dealing with this, either of which might be appropriate for your specific application. We didn't want to mandate just one. And the people writing the DTLS profile, or some of the people writing the DTLS profile, thought that this was a very good mechanism to include. And then I felt it's generic enough, it's not specific to DTLS, so let's put it into the framework. So it turns out that all this processing that you had to do, like client has to send this on to the token endpoint, AS has to include it in the token, were kind of not explicitly stated. So I added text to state that explicitly. And finally, there were a number of small clarifications where the text was less than desirably clear. So I updated that. And I'm very sorry for that, especially that it came so late. But I'm hoping it will not interfere with the ISG review process. So, any more comments at this point? Good. Is DTLS up next? Yes. So, DTLS profile. I'm now wearing my Göran Selander hat. Where is he? Somewhere. No, Göran asked me to do that presentation for him. So the DTLS profile for ACE is the one of the framework-related documents for which publication has not been requested yet because we were still resolving issues. And there is a new update coming very soon. Actually, I was told Olaf is in a very different time zone now, so it might take a few cycles until we catch up in our not very synchronized discussion. But we're waiting for him to push an update. What have we been doing since the last ITF? So at the last ITF, you saw version 05 of that draft. And we're now at, I think, 08. So at some point, we found out that if you have a 401 unauthorized while you're talking to a resource server, that was being handled as a fatal DTLS error, or that people could handle that as a fatal DTLS error, which is bad because then the DTLS connection is shut down. And 401 unauthorized, you might just want to get a new access token, post that to auth info endpoint, and then continue using the same DTLS session. So we are now explicitly saying that this should be a non-fatal DTLS error. You should continue having the DTLS session so that the client can fetch a better access token, submit it, and then continue without having to redo the handshake. there was this KID parameter in the AS request creation hints, and I already talked about this. We moved this to the framework because I felt it was a generic enough mechanism to be useful for other profiles. We added a large example to illustrate the case where you would have a confirmation claim, so a claim identifying the proof of possession key that was just containing a key identifier. So before, I think in earlier versions, we were actually specifying a specific mechanism. Turns out, just giving an example of how you could do this and then saying how you actually do it is down to the application, because application handle resolving key identifiers to actual keys in many different ways would be a much better solution. So now there is a big example that shows how you could do it if you use the key identifier to derive the proof of possession key on the resource server side. But it's no longer a normative text saying this is how you do it. Then, speaking of normative, there were a few sections where we were using non-normative language, and I felt this is actually normative. Like, you must authenticate the client, you must verify the signature, etc. That felt extremely normative to me. So we adjusted that. And we compared to the OSCO profile, and the OSCO profile had a lot of very nice examples for every protocol step, and we didn't. So we felt we didn't want to be worse than the OSCO profile and added examples for each step. And finally, there is a section now, a specific section, it was hidden somewhere in the text before, about how you securely communicate with the AS. So if you're the client and you communicate via the token endpoint, or if you're the resource server and communicate via the introspection endpoint, this section tells you that you can use DTLS for this and you use it in this and that way. So that was the updates. We think as soon as we get around to posting the update that we are ready. Does anyone disagree?
So you mentioned version 23, but it's actually 24.
24, oh, good grief.
So I don't know if the update has already been pushed.
Yeah, that is for the framework. But we are waiting for version 09 in the DTLS profile. Is it? Are we at 07? Damn it. I shouldn't do these slides when I'm tired and get the numbers all wrong. This is also the reason why all the mappings took so many cycles to complete.
Sorry, Göran Selander, just one clarification on the versions here. So we're waiting for version 8.
Okay.
7 is published, and the version 8 contains the last changes mentioned here about adding the section about secure communication, and there are some editorials about the figures as well.
If you want a preview, it is on the ACE GitHub already, or rather a version of it is on the GitHub already.
Okay, so just to clarify, we're waiting for a new version for each of the drafts.
Version 08 for that one.
Okay.
The framework and the params document are where we want them to be.
Okay.
Okay, no more questions? Who's next?
Hello, I'm Francesca Palombini, presenting an update for the key provisioning for group communication using ACE. Just to summarize or recap for those who haven't seen this before, this is the message flow of the communication. So the point is to get authorization and keys distributed to clients to talk to the dispatcher and the group members. So the first part of the communication is, or of the message flow, is covered by ACE, or defined in the ACE. And the second part, so after the token post, the key distribution request and response from the key distribution center that's not part of the ACE framework. So an update on this document was concerning IANA. So we define a new general key field in the key distribution response. So just to remind you, the key distribution response is the response from the key distribution center that contains the keys. So this general key field has now a type that is defined in a new register, which we call ACE GroupCom key registry. We also define a new profile. So this is not the same profile field as in the ACE, because this is not ACE anymore. And also we have a new registry for that, ACE GroupCom profile. And we also define a new X field, which is related to the key material. So yeah, just to get some feedback, do you think this makes sense? Or any objections to that? Okay. Then, following review from Jim, we defined errors definitions on from the KDC. So if the KDC receives an error, receives a request that doesn't either verify or is not formatted correctly, we define that you must respond with a 4.1 or a 4.00 bad request. The reviewer was happy with that. So if no objection, we'll keep this in. Next, we have a new section about how to request to leave a group. So we define the format for this request. It's a co-op post to the resource that is associated with the group at the KDC. The payload of this request looks like that. So there is a leave field, which is just an empty array. This is basically to distinguish it from a join request, which is just the same without the leave field. Then we have, in the current draft, we have a scope that should identify the group, and then optionally the client credential, if the client wants to send that. Now we are considering that the scope is not necessary because anyway, when you send to the resource associated with the group, you're already telling the KDC, I want to leave this group. So we are considering removing that.
Ludwig Seitz might be relevant if you have a KDC that serves several different groups.
Yeah, but
I don't know if that's a realistic case.
Yeah, you should have different resources at the KDC to deal with different groups, according to how we have defined. So this scope was there initially just because we wanted the same format as the request for the key distribution.
Carsten Moorman, I have a question showing my complete ignorance. Leave in single quotes means you want to have a byte string?
I think.
Let's take this offline.
Yeah. Yeah, okay. So another point is that with this request, the node can ask to leave the group altogether. So if you remember, we have a scope in this request and for key distribution and for leaving that include both the group and the role the node wants to have. And we consider that it only makes sense to request to leave the group altogether. So you cannot ask, oh, I was a requester and a listener, now I just want to be a listener. We don't have that. If you leave the group, you leave the group altogether. A client can re-request to join a group without contacting the AS as long as the token is valid. So this means that in this message flow, the client can just do the key distribution request and response. It doesn't need to redo the authorization request, response, and token post if the KDC still has the valid token. So Any other comments or objections to this? Okay, so next point. So this is something that is not in the current document, but we are considering adding it, and we would like to hear the working group feedback. So right now, the scope is defined, as I was saying, with an array with the first element is the group or the topic, and the second element is the role. So the role is not defined. Specific profiles of this needs to define exactly what the format is. So it could be a requester, it could be post-get, it could be something else that defines of this type. So now we're considering that we might want to add finer granularity on operations and resources. So rather than say, I want to be a requester or a broadcaster in this group, you might want to say, I want to be able to access that resource using post and this other resource using post and get, or something like that. So do you think this makes sense?
Yes, it makes, Peter van der Stok, it makes sense to me, but I would associate all this granularity with something which is handled by the authorization server and not by a simple request.
Yes, this will be a change in the whole message flow, so that wherever the scope appears, it will be like that.
Ludwig Seitz. I like fine granular access control. Just a quick suggestion, if you actually implement a way of expressing that, have a look at Carsten's AIF draft. I don't know where that's hanging around. Is that?
It's expired.
It's expired, sadly.
What is the draft?
Ask him.
AIF, okay.
I'll mail it.
Okay, thank you. Yeah, but I don't hear objections, I hear some support, so I think we'll go ahead and implement this and see if there is more comments. Finally, we had a request from Jim to add some text about the key redistribution initiated by the KDC. So right now we have this section and it covers, or it gives some example of how the KDC can distribute the key material. So the first one is using unicast request to each client over a secure channel. And this is the one that is very well specified and described in detail. And then we have these other points, which are for now only examples, using observe, using pubsub, using multicast. So of course, every example needs different security properties and requires different security associations between the KDC and the group members, which is why we did not go into details and describe all of this, but just give examples. So do you think we need to expand on the others?
A clarifying question. With multicast, do you mean group communication?
Multicast.
Multicast?
Yes.
Oh dear.
Yeah.
For the first case, or does this mean that my client now has to act as a server so it can receive requests? Because the other method I assume was client polling.
No, that's the client poll basically. That's okay. Using unicast means the client will send a request, or yeah. Or yeah.
I would be happy to see the multicast being addressed, but I'm not sure it's gonna help.
Yeah.
I mean, clarifying the position at least.
Yes. Yeah. Maybe you can take a look at the section and say exactly like how much more details do we need to go into, because that could become huge.
That's probably it's better to say we don't deal it because of this.
That's what we do right now. We say you could do it in these other ways, but you need to be careful because you need different security associations and yeah.
But I think a next draft could be about.
To see.
Ludwig Seitz, quick comment. When you design these mechanisms, keep in mind you don't want to require clients to be listening on the network.
Yeah.
Whatever mechanism you finally design, because the clients might be the battery-driven devices,
Yeah.
and listening on the network is the most costly thing you can do in terms of battery power.
Yeah. Okay, that was it. So I think if Jim, you were the reviewer, if you're happy with this, we'll do the small change, and then we don't foresee other changes. So like maybe more reviews or.
Hello everyone, Marco Tiroca, RISE. This is an update on another document following ACE-KGroup.com as a specific instance of it for joining OSCORE groups using ACE. And just to give you a recap, the first part, just as in ACE-KGroup.com, of course, is purely ACE. It's about having the node that wants to join the OSCORE group acting as ACE client, contacting the AS to get an authorization token to post to the group manager acting as resource server. And if this goes fine, the non-ACE part starts where the client asks the group manager to actually join the group through a join request and gets in the join response the material to actually derive the group OSCORE security context, and then can continue with communication with the group members. What is out of scope of this document is reusing possibly the very same AS or another one to get access tokens to access resources of the group members, or to even actually communicate with those group members. That's just about the group OSCORE document in core. This document was adopted end of last year, and there was a resubmission of version 0 of just the latest version we had as individual submission. So this update is about the work in these latest months, plus pending updates that we had end of last year already. But today I'll focus mostly on two big updates only, out of which, of course, really the IANA registrations followed, and hopefully ask for some feedback from you. The first big update is about restructuring the way the join response message is shaped compared to the previous non-adopted version. So it's still a CBER map. Now, of course, it follows the main model described in ACE-KGroup.com in the first place. We have key type defined in ACE-KGroup.com. Here we value group OSCORE security context object that we register in the dedicated IANA registry. And that's why, in fact, the key parameter following is, in fact, the CBER encoded version of the OSCORE security context object defined in the OSCORE profile, from which we take essentially as they are the parameters within the red frame with values consistent with this case. Plus, we are defining two additional parameters registered as new parameters for the OSCORE security context object. They essentially indicate the counter-signature algorithm used in the group, and optionally, if applicable, the specific parameters to be considered for that algorithm. And this is also consistent with related recent updates in group OSCORE. As to the new profile parameter defined in ACE-KGroup.com, also here it has value co-op group OSCORE registered in the related registry. And we just use consistently other following parameters from ACE-KGroup.com. This was the first update, and when working on this, we noted another issue we hadn't thought about before. Right before joining the group, meaning right before sending the join request to the group manager, the client is supposed to provide some public key to the group manager, but in general, it doesn't know the exact counter-signature algorithm and parameters used in the group, so it may not know the exact format for the public key that the group manager is expected to be used in that group. This is a problem, and we propose now in the current draft 3 possible approaches to address it that are just complementary and don't interfere, don't exclude each other. The first one is the client just blindly attempts to send a join request, including its own public key in some format, the only one it knows, the most convenient for it at that point in time. It may be the wrong one. And in that case, the group manager sends a first join response, not really to provide the actual key material to the client yet, but just to indicate with a new key info parameter we define here, no, you should actually try again. This time, please include your public key according to a format that makes sense for the counter-signature algorithm, parameters we use in the group. And so right after that, the client has to try again, sending a new join request, this time including the public key according to that format. So it's a blind attempt. The second approach instead is about coming to an agreement already during the token post request and response that happens right before issuing the join request. So the client, in case of doubt, of course, can explicitly ask the resource server for an indication of the counter-signature algorithm to be used. This time including the client itself, key info parameter, side by side with the access token. And in this case, the key info parameter, well, we chose it to be just a CBOR simple value, just to be highlighted as a flag, essentially. The group manager must reply in case that flag is raised, essentially, or may reply anyway, just to be sure to indicate the right thing, and reusing, again, the same key info parameter, indicating the algorithm and possibly parameters. So now the client knows what to do and goes for a first join request already, including the public key in the correct format. Please go ahead, Ludwig.
Ludwig Seitz, comment on approach 2. You are now modifying the format in which ACE expects you to post tokens to the authorization endpoint, authorization info endpoint. Because right now in the framework, the expectation is you get like the raw binary data of the token, not in any wrapper. And now since you're adding a parameter to that, you're changing that to be like a map or an array or map probably if you're using parameters.
Isn't this done also in the OSCORE profile?
Yeah, Ludwig, you haven't implemented the OSCORE profile yet, have you?
Okay.
So we thought about this also because, yeah, we had a precedent to exploit that we could reuse conveniently. Okay, a third possible approach is just that, well, the client learned the right expected format of the public key to be used in the group in advance somehow when discovering the OSCORE group, for instance, using an approach we are proposing for that in the core working group. Implementation-wise, I'm working on implementing this draft in Californium building on Ludwig's implementation of ACE. I worked especially on that branch, but during the week we actually merged it into the master branch. So if you made the pull, you find everything I've done so far, and the purely ACE segment is done, actually. I still have work in progress on the join response, essentially to actually populate the OSCORE security context object with the right values. That shouldn't take too long to do. So I plan to continue on this, of course. So to summarize, it's mostly document-wise about the two big updates on the new structure of the join response, aligned with the one in keygroup.com, just specialized as to values and exact content. And 3 possible approaches, complementary and orthogonal with each other, about having the client and the group manager agreeing on the public key format expected in the OSCORE group so that the client can provide it correctly upon joining. So we would mostly need, I would say, feedback on these 2 points, mostly, and of course, on the document as a whole. That was it.
So in the hackathon, we did some interop testing on getting the group message key format running, which is a core document, and we got most of the way there. The intention is to basically start testing these last 2 documents at the hackathon in Montreal. So if people have implementations or want to look at implementations to bring along, please do.
Thank you indeed.
And which are the implementation we could interrupt in Montreal?
For Grupo Score, just to mention, I can think of 3 for sure, hopefully more. For this one, it's only me right now, as far as I know. I hope for 2 at least. 3.
Okay, good.
Thank you very much.
Try to get that right. I'm Chidam Shankul, presenting the MQTT TLS profile. First, I want to give you a bit of a motivation why we submitted this profile. MQTT is an OASIS standard. However, while it makes security recommendations, it leaves the authorization solution to the responsibility of the implementation. And when we were searching with my colleague Anthony for authorization solutions for MQTT, we basically ended up in blog posts. So when we submitted the first draft describing MQTT, TLS, and how it works with ACE, we also approached one of the main authors that work on authorization solutions, OAuth2 style authorization solutions for MQTT, and who used to participate in OASIS MQTT Technical Committee to review and be a co-author on the draft, and that's Paul Fremantle. Just a quick overview of what MQTT is. It's an OASIS standard. It is a publish-subscribe protocol, and it has a centralized broker that manages message exchange from publishers to subscribers. It runs over TCP, and the MQTT specification strongly recommends the use of TLS for transport layer security. The clients can both be publishers and subscribers, but for the clarity of the draft, we describe these roles separately. The MQTT broker, we treated it as a resource server in the ACE framework, and the topics to which the publishers and subscribers publish and subscribe to are treated as resources. There are a few sample messages here that is in the scope of the draft. Of course, not every message of MQTT is in the scope of the ACE framework. The first thing that a publisher and subscriber client needs to do is to connect to the broker. After a connection is established, the publish and subscribe messages can be sent. The ping requests are also can be important. They are keep alive messages from clients to the broker. The topic subscriptions can be quite sophisticated, including topic filters with wildcards. This is important for ACE, especially this means that a single topic subscription may cover multiple resources. So for token validation, it's going to be important. A topic subscription may also include a quality of service, which basically tells the broker whether you need an acknowledgement message, and if it's needed, then is it a 2-way or a 4-way handshake. The work has gone through several revisions so far. The first 0.0 version was describing how ACE and MQTT could work based on the MQTT version 3.1. After the MQTT version 5 was published, we basically decided to cover those changes in the 0.1 version update. Just to note, this didn't obsolete what we described in the 0.0 version. It's just that the version 5 added new message flows and better error handling that actually helped with ACE-style authorization. So it's actually a positive, and we describe these extensions in the version 1. The other 2 version updates were based on the reviews that we received. After the version 1, we approached the OASIS MQTT Technical Committee, and we were an agenda item, and then we received a review from one of the participants who also published the review in the ACE work group. He was supportive of the draft. He also mentioned we might use ping requests as an early detection for token expiration. Previously, we were validating the tokens during Connect, of course, and every publish subscribe message triggered a token revalidation. But then ping requests can also be used for early detection of token expiration. So we added that as a response to his review. And then we thankfully received a review from Ludwig, and we tried our best to clarify, based on his review, the token structure and encoding, and added more to the privacy and security considerations. I think the best way to describe what we did is looking at the profile checklist at the core document and describe how MQTT TLS ACE profile works. The underlying transport layer security is, of course, TLS. The RS is authenticated through server-side certificates. At the version 3.1, we weren't able to support AS discovery. This was not possible with the current messages that we had with MQTT, but now can be supported with version 5. The client authentication and token transport, we have several methods described. Again, what we described for version 3.1 can also be used by version 5 implementers, but then other methods were made possible with the version 5 specification. For token introspection and token request, we assumed those endpoints could be HTTPS, but there's nothing stopping them being COAP or MQTT endpoints. Actually, again, with MQTT version 5, request response style message flows are supported better, so this can be better implemented natively using MQTT. Altset info interface, we worked to support it and described a way to do it in the appendix. But again, with the new MQTT version 5, this can be done better. We considered it as optional, depending on how is token passed from the clients to the broker. For that, we didn't want to be too prescriptive, so we discussed several different alternatives in the draft. If the token is passed after the TLS session is set up between the client and the broker, it can be passed in the connect message. And there are several ways of doing that, which I describe in the next slide. Of course, we can also support other descriptions like RPK or PSK modes, which may require an offset info endpoint, which we describe again in Appendix B, how it can be supported as an unauthorized topic, which is publish only to the broker. A way to pass the token, it's inside the connect message. The version 3.1, we basically did what a lot of practical implementations in the wild, there's no consistency in the implementations do, overloading username and password, basically. We decided to put username as token, and then the password could have the proof of possession data to do the validation of the keys for proof of possession. However, MQTT version 5, as I hinted before, gave us a better way of doing it. Now there is a new property in the connect message that allows us to define an auth method, which we can explicitly say ACE MQTT TLS, for instance, and then we can put auth data there, which could potentially be empty, and that could be treated as an unauthorized request, which would lead to AS discovery. Or it can have token or token data. In that case, if it has the token plus the POP data, then it could be just verified as you would do in a username password basis. If it's only a token, then you can implement a challenge protocol, which is basically, again, supported by MQTT's message flows, auth message flows. Yes?
Ludwig says, can you go back one slide?
Yeah.
If you're doing the proof of possession directly in the connect message, what are you doing the MAC or the signature on?
So we've basically thought it would be on the entire packet signed. This was a suggestion. It would be an application dependent, but we do know that that needs to be better defined.
Does the packet contain any random nonces or something? Because otherwise you have the risk that someone can replay this packet to...
That's true. We basically just relied on the randomness on the payload data, but then we would need to specifically add maybe a random nonce there as well. That's a good point. The final thing I want to talk about is the error handling. Again, in MQTT version 3.1, when a token expired, we had to be really brutal. We just had to disconnect the client under the MQTT layer. This was because there was no proper server disconnect message from the broker to the client with proper message codes, error codes. The other alternative was silently failing, and we didn't think that was a good thing to do. So in MQTT version 5, things have been cleaned up much better. Now a server disconnect is possible, and you can send a error code not authorized. Also, if you're supporting quality of service levels higher than 1, like higher and equal to the 1, then the acknowledgement messages can include a not authorized error code. However, this was also partly supported in version 3.1, but was not consistent. For instance, publish messages did not have this, subscribe messages had this, etc. Now it's more consistent, and we do have proper error codes. Also, this connection can be avoided because MQTT again brought in this reauthentication message, which might allow pushing a new token to the broker without disconnecting the client. So in summary, we thought the ACE workgroup was a good place to do a proper description of how Auth2 style authorization can work with MQTT. The work at the moment covers both drafts. This was a response to what we expected to happen. We expected that the current implementations of MQTT would support both versions, which is the case. We also see with the current version 5 a more natural way of supporting MQTT ACE style authorizations in MQTT. Compared to other PubSub submissions to the group, we do trust the broker, and a single AS at the moment controls the permissions to publish subscribe messages. The broker is a trusted party. It ends the TLS connections. However, if we were to do some more payload protection or create a confidential group of publishers or subscribers, I think there would be synergies with the GroupCom draft. That's all I wanted to say about the MQTT TLS profile. My question to the work group, is this a work that you would be interested to accept officially as a work group item?
Okay, go ahead.
Comment and my personal opinion on that question. Comment, I've been seeing a lot of IoT deployments using MQTT. So I think in the IoT space, this is definitely a very relevant protocol. And personally, I very much support this because I think if we don't have a solution for MQTT, ACE is much less relevant in practice. And I don't want that.
This is Dave Robbins speaking for BACnet, Building Automation Protocol. Yes, we definitely support this. We just, on Wednesday, we refactored our BACnet Secure Connect to make it much easier to have an adapter for MQTT as opposed to our own hubs. So either hub or broker, same thing. So the protocol works on either one. We then discussed what do we do about authorization. That's next. Right now, it's mutual TLS. You know, our own hubs. Mutual TLS, you're either one of the group or you're not. That's it. You publish and you publish, subscribe, anything. There's no fine grained. You're either in or you're out. But we know that we want to go beyond that.
Excellent.
And so when we go to MQTT, then we'll be right here in this draft saying, how do we go beyond just you're part of the family and how do we do fine grained? So
that's great
I
to hear.
support it
Thank
entirely.
That is, Hannes, although unpopular, MQTT is an important protocol, and we're also planning to add it to as a transport to Lightweight M2M in the next version of the protocol. So I definitely support this work.
Thank you.
Hello, Peter van Stok. I'm not here to say that the MQTT is very important. It's everywhere used, so I don't need to. But the second bullet, support draft IETF ACE key GroupCom, I think that's very important so that there's a homogeneity. Yeah.
I think that's also what we want to do. There's definitely a synergy there.
So I see kind of support for the draft. I guess you're looking for adoption. Is there anyone against? So I think we're going to take that to the list very soon. And please, those that went to the mics, support the draft so that we can, I mean, the working group adoption is only 2 weeks.
Thank you very much.
Me again. So this is a draft from the people at CMU who have worked with ACE, especially with the interops of ACE. And they have been studying a specific use case which they wanted to present in this draft. Clients in disadvantaged networks. So what are disadvantaged networks? Actually, it's like constrained networks, but worse. So they are like frequently disconnected, connectivity is intermittent, which is basically the same, and they are very limited. And the practical uses they're looking at, and you have a high risk of sabotage, impersonation of different entities, and device capture. And the scenarios they're looking at is like ad hoc networks for first responders, for law enforcement, and for the military. So 2 of the things they have been considering in the light of these specific extra constraint requirements is that the AS might want to revoke tokens for known compromised resource servers, and the clients want to check that their tokens are still valid before they interact with resource servers. So that reflects a bit the discussion we had on validity of the resource server authentication keys for the framework. Only here it's worse because you expect your resource servers to be captured or impersonated. So they were looking at different ways of helping the client to not use tokens that belong to a compromised RS. One way, the usual way you would like spontaneously solve this is to give the tokens a very short lifetime. And then if you know that there's a compromised RS, you just stop issuing new tokens for it. Problems with that is that you're going to be creating a lot of tokens and wasting the very limited and intermittent bandwidth that you have. And that your good tokens, or rather the tokens for good RSs, might not be valid long enough to do what you actually intend to do, because you have like an intermittent window of connectivity to your AS, you fetch a token, and by the time you need to contact the RS, the token might already be expired. So it's a bit tricky to handle the lifetime because you have conflicting requirements. So they looked at another alternative, which be to revoke the tokens at the AS and then have the client do introspection in these intermittent connectivity windows. So bit of background. We talked to OAuth people about clients doing introspection, and the message we got is it is not specifically forbidden, but not specifically encouraged. So it is possible with the introspection RFC, but we don't talk about it. So we wanted to talk about it and analyze the problem. And basically the idea is when the client gets in range of its AS, it opportunistically does an introspection on the tokens that it is holding. There's several problems with that. For example, if you allow full introspection, then attackers could just introspect tokens that they captured on the radio to learn what they contain as claims. This means you need to differentiate between clients doing introspections on tokens and resource servers, because the resource servers need to learn the claims. That's the whole point for them of doing introspection. The clients actually don't need to know that. They just need to know the active parameter for their token. And if you then can differentiate, this is a client doing introspection, this is a resource server, then you can serve the resource server with a whole set of claims, and the client just gets an active or not active parameter. The other problem is if you're using CWTs or GWTs that are encrypted, which you typically would want to do in such an environment, because you need a self-contained token and you need a token that an attacker cannot see the content of, then the AS needs to decrypt the token when he gets an introspection request on that token. So usually the way you can do that if it's a resource server is you know which is the resource server, so you know you can like map that token. But if it's a client, typically the AS would not know what kind of token is this? How can I see which token this is? And decrypt it to find out how it matches to the tokens I issued. So you need to find the key that the AS originally used to encrypt this token. And this just requires us to include a key identifier in the COSI wrapper of the token so that the AS can easily decrypt the token, find out, oh, this is the token I'm being asked to introspect. I mean, you could iterate through all the tokens that the AS has issued and just search until you find the one that matches. But we were expecting that this might be a lot of tokens, and you'd rather not want to do this, especially if the cost is only adding a key identifier in the header of the token. So this is the problems they have looked at. There are more problems with this specific environment. And the questions the authors would like me to ask you is, would there be interest in the working group to explore these specific problems or this problem specific to this, type of scenarios in this working group?
Jim Shaw, the individual. I found the document interesting, but I'm worried that it really wasn't exploring the entire problem, because it didn't, for example, talk about revoking clients. I mean, it was not clear how a resource server could do this opportunistic checking, given that it is only intermittently seeing the AS, and it probably didn't see the client token until after it saw the AS. Obviously, the AS can know that it revoked an RS and not permit it to do introspection. But it's not solving the other half of the problem seemed kind of, or at least not even discussing the other half of the problem seemed odd.
Well, it's a 0.0 version, so there's room for improvement. But thank you for that feedback. I will relay it to the authors and we will see if we can address that issue. Carsten.
Carsten Mohrmann, there is a whole working group that works with this kind of networks, the DTN working group.
Oh.
So maybe it would be worth getting some DTN people involved. DTN started out as a research group attaching collars to zebras and things like that. So they know about network problems. I can imagine that they would be interested in getting bits and pieces that they can use for authorization in these networks.
Good. Any more comments?
So my feeling is that the document is not yet for call for adoption, but the topic is of interest, so the discussion should move on. That's my understanding.
Yes, I'll relay that to my co-authors. Thank you.
behind or did you steal it?
Sir? Oh, that's fine.
So you're Ludwig?
So, as for today, we've changed roles. So I'll be Ludwig. It seems we've reached to the if time permits part of the agenda. And this is, my name is Göran Selander, and this is a reminder, sorry, for the notes. And this is a reminder about work that we have started a couple of years ago, which has been resting for a while. And I'd like to hear if people are interested in that. We'd like to continue this work. So there was a virtual interim 1.5 years ago discussing certificate enrollment for constrained devices. And there were 2 candidate solutions discussed. One, the protecting of enrollment using EST and DTLS. So that's the EST CoAP-S draft, which is now done. And then there was another proposal, which was looking at protecting EST payloads on application layer. And that's the EST OS-core draft, and that's the one I'm talking about here. And the questions was asked for the working group, for the 2 solutions, which one should we work on? And the answer was do both, but start with EST CoAP-S.
No, the other way around.
So that's...
Start with DTLS.
Sorry?
Start with DTLS?
Yeah. Start with EST CoAP-S, the DTLS version. And so that's done now. And we intend to restart the work on EST OS core. So a reminder of how it works. It's basically addressing the problem, or for the same reason as EST CoAP-S is a good idea, that you already have implemented a security protocol, in this case a transport layer security protocol, and you want to reuse that for protecting enrollment. That's the same rationale here. Assume that you have devices who are implemented OS core and a key exchange protocol, which we use the name ad hoc as a placeholder. Then how would you reuse that? You don't want to have multiple communication security protocols. You'd like to reuse that communication security protocol for protecting the enrollment. So that's basically the problem statement. And it turns out it's very much of the EST CoAP-S translates directly. So that's simple. It's not like a completely new enrollment protocol. It's basically reusing what already exists, but protecting it on application layer rather than on transport layer. But there are some slight differences. So for example, the EST with OS-core, you could use end-to-end REST. So you could change between CoAP and HTTP. So a client could start with CoAP, and the enrollment request could pass an CoAP to HTTP proxy and end up in a registration authority, and you can have end-to-end security. And it works over UDP or over DTLS or TLS or other transports. But there are minor differences. But basically, we would like to have an enrollment protocol for these devices which only implement OS-core. And the next steps, well, is to flesh out these details. Now, EST CoAP-S has developed a lot and matured, so we'd like to take over those details. That's one first next step in the comment on this.
Yes, Peter van der Stok, one of the EST CoAP-S authors. Yeah, I agree that now having worked with OS-core, there is not too much work to transport one to the other. So agreed. You will need ad hoc or something similar to get the whole thing working. Yeah, I also agree about that. I don't, well, from my experience with my background, I don't see this being used for a general distribution of certificates over the network, but I can very well see the use in the Brisky environment, where at this moment we have problems with specifying proxies, which should be very careful not to look at the DTLS contents, etc. Okay.
Thanks.
Carsten Bormann, since we are being slowed down by waiting for ad hoc to complete, maybe we can add some fun here and do other certificates than X509 certificates in the process?
So this is completely independent on what kind of certificate you use.
Well, no. When you look at SQLS, they have defined names to get things in certain formats. So that, I mean, it's not like the protocol changes, but there are some details that actually cater with the fact that we have different formats for different things. So maybe it's just worth looking at this.
Different format for the different things, or different format?
So I think what Carsten is saying is that this doesn't necessarily have to be X509 certificates. And that's somehow what is assumed in the ESD Co-op S setting. Okay. So that's, yes, we need to look at ad hoc also. It could actually make sense without ad hoc here in a setting where you do implement multiple communication security protocols. But the default setting would be that you have a key exchange protocol in place. And that would be ad hoc, or what it will be called now when we hopefully get this new working group running. And I will already have one other suggestion here from Carsten. Is there any other suggestion you'd like to add to this work? No? Okay. Any other comments? Thank you.
Yeah. I wasn't paying attention and forgot that I actually had a couple extra slides here. So the big one is ad hoc has been in this group, presented here several times, and it went through a SEC dispatch process. And a summary message from the current ADs was posted on SEC dispatch yesterday. For those people who would like to see ad hoc done, or for those people who really don't want to see ad hoc done, if you can get onto the SEC dispatch list and express support or whatever, that would be appreciated. The current plan forward, can I say about that, or can I not say about that?
I think so too.
All right.
Ben King, I was just going to say, if you're coming to express something else on the list, please be specific about it.
So basically right now, the intent is to form a working group without going through the BOF process. I'm not exactly too sure when people are going to start writing a charter, or create a working mailing list, but that should be announced sometime reasonably soon, I assume. Carsten
Bormann. So this group is ostensibly one of the customers of this potential work that is being summarized here as ad hoc, but really, which is an authenticated key agreement protocol that is applicable to our work here and might use ad hoc as a starting point. I think it would be a good thing to know if the people in this room who kind of are the customers of this, who would need this, would be happy with the working group being formed to work on this. I asked the same question in the core working group, and we had in-room consensus that this was a good thing to do. So I just would like to hear from a slightly different constituency whether that's also the case. I would ask the chairs to maybe consider asking that question, because I won't ask this question.
Carsten, what you asked was whether the core group was happy with not doing that in core, which was a different question. And I heard that question, and I'm fine with not doing that in core. But talking about the more substantive, and so when we had the presentation, the virtual intro meeting, the conference call, there were requirements being presented, and I tried to sort of in a follow-up mailing list discussion get a better sense of what the size requirements were. And I got good feedback on 6-dish, but I didn't hear any other things on some of the other radio technologies in terms of MTU size. So I think that would be useful together. And also there was the question about the power consumption model that was presented for the NB-IoT, and it seemed to refer to, it wasn't clear whether that was a simulation, it wasn't clear where the data came from. So that's also someone at the conference call, I forgot the name, said that they would provide, which they then never did. Since I don't know the name of the person, someone from Ericsson, maybe they can post that to the list, provide some additional feedback so that others can actually verify the results.
Hi, Roman Danilio. One of the complexities that we had in producing that summary for kind of ad hoc is that we had the discussion in so many different places. So if we want to bring comments to what was there, we would beg you to take it to the SecDispatch mailing list and kind of talk about it there. I mean, it's great that there's customers from different working groups getting endorsements, and getting that feedback is very helpful. But ultimately, please kind of bring that back to the discussion that we are having on SecDispatch.
So you're answering on that? So I think I've addressed all those questions in the SecDispatch mailing list. Could you please go back and check and see, because both the LoRaWAN MTU sizes were discussed, and they are also presented in the slides. As for narrowband IoT, power consumption is also extensively described, that it's not a critical, since there is a fragmentation scheme built into narrowband IoT, there are no critical MTU sizes. It's basically handled. That was stated multiple times. Please read the list and come back with questions on the SecDispatch list.
I'll summarize what Roman Danilio, I'll summarize what I said before. We believe that the consensus opinion and kind of all the bits are in our write-up. If we are incomplete and we think we need to kind of flesh that out, whether it's with kind of additional details or otherwise, it would be, again, very helpful to us if we poked at the specific things we said on SecDispatch.
Ari Keränen, on the question in the core group, I think the core of the question was, okay, do we want this done? And there's a lot of support. Yes, we want to get this done. And the way forward seemed to be reasonable. I guess that's what we had consensus for.
And procedure question, might it be possible that during the discussion of ad hoc in its special working group, some of the results may go back here to this working group, and we could look at the documents and comment on them?
Yeah, that would definitely, yeah, we can definitely advertise it onto additional lists.
Okay.
Okay. I'm reluctant to actually do that call. So I think not. The one other thing that I wanted to bring to people's attention, Hannes wrote a draft for using CWTs as the certificate in TLS. And I actually implemented it over the hackathon. It seems to me that it may be something that this group wants to explore deeper at some point, because it provides an analogous behavior to the PSK, where you can send the token as the identifier. So you can just send the token as the certificate directly without having to post it to the authorization point. Okay, is there anyone else who wants to bring up any business?
Could you mention the interim, Francesca?
The core and CBOR working groups have been holding alternating weekly interim meetings. the intention is for us to get together and set up a schedule, hopefully to go at least through Singapore. And one of the things that we are looking at doing with that is to offering occasionally some of those slots to other working groups so that we have a fairly predictable time that a lot of people can get onto it. So we will be sending out a doodle poll, and we will be including this mailing list on that doodle poll, and we would like you to give us feedback so we can help in terms of deciding a consistent time that we can get the most people and the right set of people. If we do have an ACE interim, it will not necessarily be at that time, but it will be one of the options. Okay, go find your airplanes.
Which also means that some progress has to be made between the interim meetings. Okay. So I guess we're done. Thank you, and see you all in the next interim meeting.